I have a function f of x equals radical x. That's x raised to the 1/2 power. I want to know f of 24. I want to know f of 24, but it's too difficult. But I can easily do f of 25. F of 25 equals 5. So I have a point on the graph now. X equals 25, y equals 5. 25, 5 is my point. So I'm going to draw a tangent to this point. 25, 5. So I need m. How do I get it? How do I get m? Well, I just take the derivative of f of x. F of 25 equals 5, and I have a point 25, 5. Now I said I got to take the derivative of f of x. F of x equals x to the 1/2 power. F prime of x will be, well, 1/2 x to the 1/2 minus 2/2 power. Could you show me the steps? I'll be delighted. First, I take the 1/2, I put that in front of the x. Then I subtract 1 from the power. Now I'm going to reformat it. 1 over 2. 2 is in the denominator. X to the negative 1/2 power, rewritten. That goes right into the denominator, but it goes in as a positive, as an x to the positive 1/2 power. So what's the derivative? So what's the derivative at x equals 25? Well, we have 1 over 2x to the 1/2 power. That's our derivative. Now we plug into the x spot the 25. X to the 1/2 power is really the radical sign. So f prime 25 equals 1 over 2 times x to the 1/2 power, 25 to the 1/2 power, or the square root of 25. F prime 25 equals 1 over 2 times the square root of 25. The square root of 25 is a 5. 1 over 2 times 5. That equals 1 over 10. So the derivative is 1/10. We can now use the point and the slope. To do what? To form an equation for the tangent line to f of 25. The point-slope formula is perfect for this. Y minus y1 equals m times x minus x1. That's the point-slope formula. So we know that f prime of 25 equals 1 over 10. The point in question is 25, 5. So the equation for the tangent line at 25, 5 is y minus y1 is 5, y minus 5 equals m times x minus x1. 1/10 times x minus x1, the 25. 5 was the y1, 25 was the x1. Y minus 5 equals 1/10 times x minus 25. The equation for the tangent line then at 25, 5 is y minus 5 equals 1/10 times x minus 25. Well, we add 5 to both sides, and what do we get? Y equals 1/10 times, well, 1/10 times x is 1/10 x. 1/10 times negative 25, well, just move the decimal spot back 1 point, and you got negative 2.5. Negative 2.5 plus 5 that we moved over from the left-hand side of the equation. Finally, we have y equals 1/10 x plus 2.5, because negative 2.5 plus 5 is positive 2.5. The equation for the tangent line then at 25, 5 is y equals 1/10 x plus 2.5. What does y equals the square root of x look like anyway? It looks like this. And here's your 25. And here's your 24. Yes, 24. That's the guy we're so interested in. Okay, so far, the equation for the tangent line at 25.5 is y equals 1/10 x plus 2.5. Now we draw the tangent line. Here's a close-up. Question, what are we going to do? Answer, now I'm going to plug x equals 24 into our tangent line equation. What am I going to plug it into? Our tangent line equation. You mean the tangent line equation that we just developed for x equals 25? Yes, that's what I mean. But how will that help? How will that help us in any way, shape, or form? Because it's going to give you an f of x that's on the tangent line. On the tangent line. That f of x on the tangent line is not going to be on the curve. So how is that going to help you? It's going to miss the curve. Well, that's exactly right. Now watch. I take the formula 1/10 x plus 2.5. I take the x, I plug in 24. It says 1/10 times 24 plus 2.5. So what is 1/10 of 24? Well, just move the decimal spot 1 point to the left and you get 2.4. 1/10 of 24 is 2.4. Now my equation says 2.4 plus 2.5. Now I add these two up, and what do I get? So what do you get? You get 4.9. 4.9. It missed the curve. It missed the curve. Yeah, but not by much. In fact, it'll closely approximate the real value that is on the curve, which is 4.89. 4.89. If you take the square root of 24 on your calculator, it'll give you 4.89. And while this point is not on the curve, the one that we just got, while this point is not on the curve, it is a very close approximation to the true f of 24 value that is on the curve, which is to say that 4.9 comes pretty close to 4.89, or 4.9 closely approximates 4.89. So we use the linear equation for the tangent to f of 25 to approximate the value on the curve at f of 24. And this is what linear approximation is all about. The end. Have a nice day.